All right, last video for the key that we're making, this new video key. Let me write Bruce Banner's name here. All right, sweet. So let's look at number 17. The following reaction is used to generate oxygen gas in breathing equipment. We're given some reaction here. Balance the above equation by putting coefficients in the blanks. So I will spare you walking through how to solve these equations. If that's still something that you struggle with, there's an extra practice sheet on Sakai that you can look at. All right, but I think this is just straightforward balancing problem. All right, part B. How many grams of oxygen can be produced when 6.20 grams reacts with CO2? Okay. All right, so we're starting with potassium peroxide there. Potassium peroxide, okay. And we're reacting with CO2 gas. All right, so 6.20 grams KO2. And this is not a limiting reagent problem. I think a lot of people thought that it might be, but if you're told that you have excess of something, you know that this other reagent is automatically limiting. Okay, so I've got 6.20 grams. I need to go from grams to moles. So I use my molar mass that I calculate from the periodic table. 1 mole potassium peroxide, okay. And then this was an interesting step that a lot of people really struggled with. When you are going now from moles, grams. When you're going from moles of one thing to moles of another thing, you have to use the correct stoichiometry. You absolutely have to. A lot of people did a 1-to-1 relationship, and that's not correct. You know that for every 4 moles of potassium peroxide, you're going to produce 3 moles of oxygen gas. All right, you have to use that correct stoichiometry. Now the question is asking you for grams of O2, so I have to go now from 1 mole O2, and this is where some people, I think, use the incorrect molar mass. Instead of putting 32, which you should, they put 16. They forgot that oxygen is diatomic here. All right, let me just cross stuff out. Excuse me. And you should get 2.10 grams of oxygen. Some people got 2.09. That's fine. Close enough. All right, let's go down here to number 18. All right, you find a dusty brown bottle of an unknown liquid on the back shelf of your lab. You suspect that this bottle contains benzene. Ooh, it's a carcinogen that would need to be disposed of carefully. Indeed. The density of benzene is given as 0.877 grams per mil in a chemistry reference guide. So you look at pull out a 15 mil sample, and you figure out that it has a mass of 13.2. Do you believe the substance could be benzene? Show your work. This is, fairly straightforward problem. It's just a density problem. So density, as we know, equals mass over volume. So let's see if we can figure out what the density of this unknown liquid is. The mass that we calculated was 13.2 grams. The volume that we calculated was 15.0 mils. So the density is 0.880 grams per mil. Could this substance be benzene? The answer is yes. This substance could be benzene. These are really close numbers. Really close. That's within, the realm of a measuring error. All right, so this definitely could be benzene. But notice when I write my answer, I say yes. This could be benzene. I don't know that for certain. I'm not going to stake my life on it. I'm going to, take it seriously enough that, I'll probably call, EHS or somebody to pick up this bottle and tell them it's probably benzene in it. But I'm not going to say that for absolutely sure. I can say it has the same density as benzene, but maybe further tests would be required to say anything, for absolute certain. If you said, yes, this is benzene on your test, I think I just wrote could be, but I didn't take off points for it. Just know that this is a possibility, but not necessarily the absolute truth. All right, thus ends the Chem 101 exam. Hopefully that clarified some stuff for everybody. And yet another phone call, but perfect timing this time.